Hi everybody, Mr. Riedl here. Today we are going to be learning about prime factorization. Prime factorization. And prime is basically a number, a special type of number, which you may have heard about before. We'll talk more about that. Factorization is a big word that basically means we're going to be making factors. Factor is the root word here, or factorize. We're going to be making factors from bigger numbers. And factors, for those of you who don't remember, are basically different parts of a multiplication problem. And the shun means this is a noun. So the verb is factorize, and then the prime factorization is the noun for what we're going to be doing. And the goal for today is I will be able to find the prime factors. Finding the prime factors is factorize. Of composite numbers we'll talk about in a minute, using exponential notation. Basically, that's a way of writing with exponents. Okay, so let's go ahead and get started. Okay, so let's start with a little bit of review. Let's talk about prime numbers and what prime means. What prime numbers mean is that they have factors of just themselves and 1. For example, 2 is a prime number. See how 2 is purple here. So 2 is, what the factors of 2 are 2 times 1. So 2 times 1, the factors are just 2, which is itself, and 1. So that is are the only factors for 2. 5 is another prime number. 5 is a number where the only factors of 5 are 5, which is itself, and 1. Okay, 5 times 1 is the only way you can get 5. A number like 8, however, 8 is not prime. Numbers that are not prime, also known as composite numbers are not prime, and they are all the white numbers on here. And this is just a list from 1 to 100, but it would keep going infinitely because prime numbers and composite numbers go infinitely because there's an infinite number of whole numbers that exist. So not prime would be 8, for example, because 8 you could have 8 times 1, but you could also have 4 times 2. These are all different examples of factors of 8. So that is the main difference between prime and composite, or prime and not prime numbers. And this is a good chart to help you if you don't remember if it's prime number or not. Now, why are prime and composite numbers so important? When you deal with money and when you deal with larger numbers in your life, in whatever capacity that you're going to be using numbers in your life, they are important because they're the building blocks of understanding these larger whole numbers. For example, like when you were learning how to read, you learned the individual letters of each word, and eventually those letters turned into words, and those words turned into sentences. Well, that's not actually a sentence, but you get the point, right? You have to learn the basics, the building blocks, in order to understand the bigger picture. It's the same with prime numbers. When you break down numbers into prime numbers, you're going to understand the bigger picture more as you go along. The multiplication chart is also going to be super helpful when we are doing these problems because it's important to know what the factors are for the bigger numbers. For example, 24, there's going to be multiple factors for the product of 24. We're going to be 6 times 4, or also 24 is over here. The factors could also be 12 times 2, or another example might be 8 times 3. Okay, so there's many different factors for certain numbers. And the way we would list the factors, 1 times 24. So it would be 1 times 24. 24 would be on this side. We did factor rainbows earlier in the 2 times 12. 2 times 12. 3 times 8. And lastly, it would be 4 times 6. 4 times 6. So these are all the different factors of 24. And we could use this chart to find many different factors. Some of them aren't on this chart, but this can help with some of the places where we can start with some of the numbers we're doing today. Now, Some of the first problems in IXL that we're going to be working on is knowing what prime factorization means. Okay, so if it says, what is the prime factorization of 5? If we knew that back on this chart that 5 is already a prime number, then that will help us to know how to solve the problem. So what I'm actually going to do is I'm going to copy this image, and I'm going to reuse that as we go through. The question is, what is the prime factorization of 5? I'm going to paste this here, and I'm going to say, oh, okay, I can look on this chart and see, oh, 5 is already prime. So I know that the prime factorization of 5 is going to be this one because it's already a prime number. So this is going to be our answer here. And I'm going to click submit. But if I were to look at all these other ones, I know that 3 times 3 is 9, and 2 times 3 is 6, and 2 times 2 is 4. So since this is the only one that equals 5, I know that that is the correct answer. So the next problem says, what is the prime factorization of 9? 9. Okay, so I don't think 9 is prime. Let me look at the chart again. Yes, 9 is not prime. So 9 is a composite number. So I know that it is going to have factors other than just 1 in itself. And I know right here that this is not going to be correct because I know that 9 is not prime. So I'm going to cross that off and eliminate that. Okay, 3 times 3, I know that that is 9. 3 times 9, I know that that is 27. So I know that that's incorrect. And then 3 is here, and this is a prime number, so that's not going to work. Okay, so I know that this is the answer because of the fact that 3 times 3 is 9. And that is how I factorize the number 9 by finding its prime factors. So that is correct. Okay, so the next problem says, write the prime factorization of 18. Okay, so 18 is the number that we're going to be working with right now. It also says, order the factors from least to greatest. For example, 2 times 2 times 3 times 5. Okay, so they're in numerical order. Now, in this example, factor trees are super helpful because they're ways that you can break down a bigger number into smaller factors. And there's multiple ways of doing this. Method 1 for a factor tree is on this side, and method 2 is going to be on this side. So I have method 1 and method 2 for doing my factor tree. So I'm going to start with 18, the prime factorization number that I need to start with. 2 methods. 18 is the number that I need to factorize. So I need to find the factors of 18. Well, there's 2 ways of doing it. If I know that the factors of 18 are 2 and 9, because 2 times 9 equals 18, then I could do it this way. Or I could do it this way, where I know that there's other factors of 18 other than 2 and 9. There's also factors like 3 and 6. So 3 times 6 is 18 and 2 times 9 is 18. So there's different choices. And when I break these down, I'm going to get to prime numbers. And what I'm going to do is I'm going to circle these. I'm going to circle 2 because it is prime. 9, however, is not prime. That can be broken down even further into factors of 9. So if 9 gets broken down, I know that there's only 2 other factors for 9, and that is 3. 3 times 3 equals 9. If I know that 3 is also prime, based on my chart here, based on my chart, I know that 2 is prime and 3 is prime, and those are the numbers that we are left with here. So method 1, the numbers that I got for 18 is 2 times 9, and 9 is the same as 3 times 3. So it's going to be 2 times 3 times 3. Okay, so this is the prime factorization of the number 18. Over here, I got 3, which is prime, so I'm going to circle it. But I also got 6 here, and 6 is not prime. As you can see, it is a composite number. So I can break down 6 even more. I can find the factors of 6, and I know that they are going to be 2 times 3. 2 times 3 equals 6, so 2 is prime, and 3 is prime. So I'm going to circle these. Oh, look, I got the same numbers. They're just in a different order. The way that I'm going to write this is, if I wrote them in this order, it would be 3 times 2 times 3. However, it actually asks me that to order the factors from least to greatest. Okay, so this one would not be in the correct order because it goes 3, then 2, then 3. But for this one, it is correct. So it's 2 times 3 times 3. Both of these equal the same thing. They both equal 18, but I'm going to write in my answer 2 times 3 times 3, and then submit that, okay? Because it needs to be in the correct order. So this is basically the bigger picture that I was explaining at the beginning when I was talking about the purpose of why we learn about prime numbers, and that is so that we can understand the building blocks of larger numbers and the way that we can do it in different ways. Like we can get 18 by multiplying 2 times 9, but also 3 times 6. So when we break apart these numbers, we can see that different building blocks can eventually create the same thing, even though there's different methods of doing it. The next problem says write the prime factorization of 12. Okay, so there are going to be multiple methods of doing this as well. One method would be doing a factor tree where I'm breaking it down into 2 times 6, because I know 2 times 6 equals 12, or if I break 12 down into the factors of 3 times 4. 3 times 4 equals 12, and 2 times 6 equals 12. So what I'm going to do is I am going to circle these prime numbers. So 2 is prime, so I'm circling 2. And then 6 can be factorized into 2 times 3. And 2 is prime, and 3 is prime. So the answer to this is going to be 12 is equal to 2 times 2 times 3. 2 times 2 times 3. Or the same as 2 times 6. 2 times 6 here. 2 times 3 is 6. Now, if I just do it this way, I would just write the answer here because I know that they are in order. 2 times 2 times 3. However, if you started this way because maybe you first thought of 3 times 4, this would work too. It would just be out of order because if we factorize 4 into 2 times 2, then I would get 3 times 2 times 2. 3 times 2 times 2, which is correct. 3 times 4 is equal to 12, but it's just out of order. So that's why I asked you to order them from least to greatest to get them in the right order. All right, so the next set of problems are a little bit more complicated because you have to write them in exponential notation. Basically, you have to include exponents, okay? And this is what we learned in the last lesson is how to write exponents and what exponents mean. Write the prime factorization of 9. Okay, so 9 is the number that we are trying to factorize. And we just know, because we've done this already, that the factors of 9 are 3 and 3. So it's 3 times 3, right? So 3 times 3 equals 9. Now, how do I write this here? It says use exponents when appropriate. So this is exponential notation. And what we learned in our last lesson is 3 times 3 is the same as 3 to the power of 2. Or written differently, if you want to write using the dots, like this dot right here, this is talking about multiplication. 3 times 3 is equal to 9, but we would write it as 3 to the power of 2. Now, the way that I would write this answer here in this box is I would type this, I would type it, not write it. I would type a 3, and then I would push this button here, which would make it go into the little exponent section here, and then I would type a 2 like that. So then it would be 3 to the power of 2, and then I would press submit. The next problem says write the prime factorization of 40. So I'm going to write 40 here. Now in my brain, when I look at the number 40 and I think of factors of 40, I know that there's many different factors of 40, but what comes to my mind first is 4 times 10. 4 times 10, because I see that as a multiple of 10 in my brain. But there's multiple ways that you could solve this and get the same answer. And if we take a look at this chart of prime and composite numbers, I will see that, 4 and 10 are both composite numbers. So that means I'm going to have to break these both down even further into prime factors. So I know based off of a previous problem that 4 is 2 times 2. So I broke 4 down into 2 times 2. So I'm going to circle these prime numbers. And 10, I know that there's only 2 other factors of 10 other than 1 and 10, and that is 2 times 5. So I know that 2 is prime, and 5 is here on the prime numbers list as well. So I have broken 40 down into its prime factors. 40 is equal to 2 times 2 times 2 times 5. So these are the prime factors for 40. However, it says use exponents when appropriate and order the factors from least to greatest. Okay, so what it's asking about is these right here. These are repeated numbers, and I need to use exponents in this case. Okay, so how would I write 2 times 2 times 2 in exponential notation? Is I would write it as 2 to the power of 3, because it's 2 multiplied by itself 3 times. And then I would just bring down this times 5, because I know that 2 to the power of 3 times 5 is equal to 40. So basically, I'm just consolidating this here. I'm just grouping these 2's multiplied by each other into 2 to the power of 3. And then since 5 is a different prime factor, that is listed separately. So it's 2 to the power of 3 times 5. So the way I would do this, if I was typing it, 2, and then I would push this button to make it go into the exponent section here, 2 to the power of 3, and then I would push this button again to go back down, and then I would push the multiply button times 5. So remember, the X or the multiply sign is the same as the dot. They both mean multiply. And then I would submit that, and that would be the correct answer. 2 to the power of 3 times 5. All right, for the next example, write the prime factorization of 50. Again, like I mentioned before, when I see the number 50 or any multiple of 10, I automatically think of 5 times 10. However, I'm going to do it differently this time, because maybe some of you look at this and you think of 50 cents and you think, oh, 50 cents is like 2 quarters. So 2 times 25. 2 times 25 cents. So I know that 2 is a prime factor, but 25 is not, because I know that 25 is the same as 5 times 5. 5 times 5. And I know that 5 is prime. So when I break down 50 into, when I prime factorize 50, I break it down into 2 times 5 times 5. Okay, so 2 times 5 times 5 is equal to 50. But that's not all. I need to use exponential notation. So I'm going to group these together. 5 times 5 is the same as 5 to the power of 2. And I just bring this 2 times down. 2 times 5 to the power of 2 is equal to 50. And this is how I would write it up here. 2 times 5 to the power of 2, or 2 times 5 squared. And for my last example, write the prime factorization of 36. Now, the reason I chose this one for my last example is because this one is a little bit different. This one has multiple exponents located inside of this answer. So let's solve it and see what it looks like, okay? When I see 36, I know off the top of my head that that is 6 times 6. Since 6 is a composite number, it's not prime, I'm going to have to factorize these both as well. And I know that 6 is the same as 2 times 3. For both of these, 6 is 2 times 3. So what I have here are 4 prime numbers, but they are not listed in order from least to greatest. So what I need to do is rearrange these. 36 is equal to, I got 2 2's, 2 times 2, and then 2 3's, times 3 times 3. Okay, so now they are listed in order. 2 times 2 times 3 times 3 is equal to 36. Or another way of looking at it, I could have done my factor tree differently. 4 times 9, because 4 times 9 is also 36. But what I have to do is I have to use exponential notation. So what I'm going to do is I'm going to combine these 2's, and 2 times 2 is the same as 2 to the power of 2. and I'm going to combine these 3's, and this is going to be 3 to the power of 2, and I'm just going to bring this multiplication sign down, and it's going to be multiplying this times this, okay? So basically, I just condensed this 2 times 2 into 2 to the power of 2, or 2 squared, and I condensed this 3 times 3 into 3 to the power of 2, or 3 squared. So now the answer is condensed into 36 is equal to 2 squared times 3 squared. And that is the correct answer, okay? So lots of different ways to do prime factorization of lots of different numbers. And the more problems that you do, the more challenging it will become, because these numbers will get larger, and the larger that they get, the more tree branches of the factor trees you will have to figure out. But basically, it's the same idea, is you break that number down into smaller pieces until eventually you get to the smallest pieces, which are the prime factors. So thanks for watching, and I hope you guys have as much fun as I had doing these factor trees, because man, I could just do these all day. All right, have a good day. See you later.